Alright, in this video here we're going to be talking about standard position of angles and then also coterminal angles. Alright, so first up, standard position. Alright, an angle in standard position is drawn in the XY coordinate plane so that it has its vertex at the origin and its initial side is on the positive x-axis. Right, so up here we have three examples of angles that are in standard position. Right, they're all in the XY plane. Right, the origin where the x and y axis meet, that's where we have the vertex of each angle. Remember, the vertex is where the two rays that make up the angle, where they intersect, that point they share in common, that's the vertex of the angle. So the vertex is at the origin, and then the initial side is on the positive x-axis, meaning the axis that moves off to the right. Now, to correspond this to, if you've been watching my videos and kind of following along and going in order with them, when we talked about the unit circle and like traveling around the unit circle, remember we always started on the positive x-axis as we moved around the unit circle one way or the other. In this way it was a positive direction and this way it was a negative direction. Well, this corresponds with that for a very good reason, as we'll see as we move further along. But a standard position of an angle, the initial side, it starts on that positive x-axis, just like when we were playing with the unit circle. Playing maybe is not the right word there, but just like when we were working with the unit circle, we always start on the positive x-axis. And remember, for our angles, if you didn't watch the video that I did on just angle measure in general and radians and degrees, remember a positive angle opens this way, just like when we start on the positive x-axis and we move this way around the unit circle. So a positive angle goes that way, a negative angle goes this way, just like for negative numbers when we went around the unit circle, we went in that direction. Right? So all those things correspond, they're all interrelated with each other. Right, so it helps to remember what's going on. Just when we're dealing with angles in the coordinate plane, all right, we're starting on the positive x-axis. That's just the way we do it, right? And that's just conventional mathematicians decided that would be the best way to do this. It would make things easier if we put all our angles in standard position with the x-axis, the positive x-axis, as our initial side. All right, so anyway, all right, so here we have a positive angle in standard position. Here we have a negative angle in standard position, right? The initial side is on the positive x-axis, but then it's rotating clockwise to get up to here, right? That's a negative angle in standard position. And here we have an angle that actually does one full revolution and then almost two full revolutions before it gets to what we call its terminal side, right? The initial side is where you start, the terminal side is where you end up, right? So this angle here is more than 360 degrees, right? Remember, 360 degrees is one full revolution, one full circle. Well, this one does one full revolution, and then it keeps going beyond that, right? You can have angles that do multiple revolutions. The measurements for angles don't just stop at 360 degrees. They can go from negative infinity to positive infinity. If you just keep going around and around and around, you can get huge numbers for the measures of your angles. All right, so those are angles in standard position. It's a pretty simple concept. Your vertex is at the origin, and then your initial side is on the positive x-axis. If you have that, you're in standard position for your angle. All right, coterminal angles, right? What they are angles that are in standard position whose sides coincide with each other. Right? Coterminal. If you know what words mean, like the roots of words. Terminal means the end, right? The ending. So terminal is like where the angle ends. Like as you rotate around, wherever you stop, that's your terminal side of your angle. Right? Co means with or together. Right? So coterminal means they end together. They stop at the same spot. Right? That's what we mean by coterminal angles. Right? So if you use your knowledge of language and words and stuff, you can kind of figure out what a lot of these mathematical terms mean, or at least take a decent guess at what they mean if you don't remember what they mean. Right? So that's what coterminal means. So I put up here couple example or an example of two angles that are coterminal. Right, so they're in standard position first of all. So when we're dealing with angles in the x and y plane, pretty much all the definitions and all the things that we work with, those angles are in standard position just because it standardizes everything and it makes things easier to deal with. Right, so they're in standard position. The initial side is on the positive x-axis. The vertex is at the origin. Right, so the angle, the positive angle that rotates up to here, right, by denoted by that little arrow going up there, right, that's one angle, and the one that's pointing upward is its terminal side. Right, a negative angle though, that starts on the same terminal side and goes this way and ends on that same line up there, right, those two angles are coterminal. Right, they're not the same angle. Right, because this one is a small positive angle. This one's kind of a large negative angle because you're rotating pretty far to get all the way around there in that negative direction. Right, so they don't have the same measurements, but we call them coterminal because when you graph that angle or when you draw a picture of it, the two sides end up at the same spots, right? So that's what we mean by coterminal angles. They end at the same place. All right, so what I'm going to do here is pause the recording and erase these definitions and then put up a couple examples where we find coterminal angles. Like given this angle measure, find some angles that are coterminal with that one. So I'll walk you through how to do that. Once you understand it, it's really not hard to do at all. All right, so our first example up here, we're going to find angles that are coterminal with theta equals 30 degrees in standard position. All right, so here's my angle of 30 degrees in standard position. Right, the initial side is on the positive x-axis, vertex is at the origin, and I'm rotating upwards, right? So the positive angle, I rotate upwards in that counterclockwise direction. So there's my angle of 30 degrees. And I want to find some angles that are coterminal with this one. Well, the way we find coterminal angles, kind of like you may have figured it out from looking at that picture that was up here a minute ago, but to get coterminal angles, basically what we do is extra revolutions around. Right, so if I go from here to here, that's 30 degrees. If I start on that same initial side and I go all the way around the circle and then to that same spot, well, that's 30 degrees plus another 360 degrees, right? Remember, 360 degrees is a full revolution. It makes up a full circle. So if I want to find coterminal angles, basically I just add an extra revolution or subtract a revolution. I add or subtract 360 degrees to the measure that I have, and that's going to take me another lap around and ended me up at the same spot where I was, right? So if I do 30 degrees plus 360 degrees, that's going to be an angle measure of 390 degrees. That's going to be coterminal with 30 degrees, right? 390 is 360 degrees. It's one full circle around, and then another 30 degrees beyond that, and I end up at the same spot as I did if I just started here and went 30 degrees, right? So that's how we can find coterminal angles, just adding 360 degrees or subtracting, as we'll do in a second. So if I do one full trip around and then the extra 30, that's 390 degrees, that's coterminal. What if I did two extra trips around? What if I went all the way around the circle once, twice, and then went that extra 30 degrees to get up there? Well, that's 390 plus another 360, right? Which that's going to be 750 degrees, right? So 750 degrees, 390 degrees. Those are going to be two coterminal angles with 30 degrees, right? For 750, I go one lap around, that's 360 degrees. I do a second lap around, that's 720 degrees. And then the extra 30 gets me to 750, and I end up at the same exact spot as where I was for that 30 degree angle. All right, so that's a couple positive coterminal angles. I can also find negative coterminal angles, right? If I start at my positive x, or if I start at the 30 degree angle and I go one full lap around this way from there, well, then that's going to get me to that same spot. All right, so if I do 30 degrees minus 360 degrees, that's going to be negative 330 degrees, also coterminal with these other ones, right? Negative 330 would be starting here and going almost a full lap around in that negative direction, right? A full lap around would be 360. I'm stopping 30 short of that, right? 330 is 30 less than 360. So I'm going almost all the way around, but I stop 30 degrees short, and I end up at the same side as that 30 degree angle that I started with, right? And then if I wanted to get another negative angle, well, if I did two laps in the negative direction and then stop here, if I do negative 330 minus another 360, I'm going to have negative 690 degrees. All right, so what I have now are 5 angles that are all coterminal with each other, right? Negative 690 degrees, negative 330 degrees, 30 degrees, 390, and 750 degrees. All 5 of those are coterminal. If I were to graph each one of these on the coordinate plane, they would all have the same two sides, the same initial side and the same terminal side. It's just how far do I go around the circle before I get there? That's the difference between these angles. All right, so that's the meaning of coterminal angles. So if your measurement is in degrees and you need to find coterminal angles, it's really simple. You just add or subtract 360, or do both depending on how many coterminal angles you need to find. Just add or subtract 360. Every time you do that, you're making one more lap around the circle in one direction or the other, and you're ending up with a coterminal angle. Right? So again, if you understand what coterminal means and that the full circle is 360 degrees, I mean, you're just doing basic arithmetic at that point. You're just adding 360 or subtracting 360. It's not hard. All right, I'm going to pause this now and put up an example where we do the same thing, but our angles are measured in radians, so that's going to be a little bit more difficult because now we're going to be like adding fractions and stuff. Alright, so here we have same instructions, but now our angle theta is pi over 3 in standard position. Now notice, for the degrees, when the angle's in degrees, it has that little circle, that little degree symbol there. If they give us an angle and it doesn't have that degree symbol, we assume then that it's in radians. They don't have to say pi over 3 radians or RAD. If they don't give us the degrees, it's going to be in radians, right? So if you're ever not sure, that's how you can tell. If you don't have that degree symbol, your angle's in radians, right? So pi over 3 radians. Well, here's an angle of pi over 3, which corresponds, if you remember the unit circle, this finger here was pointing at pi over 3. Well, the angle that points at that point on the unit circle, that's an angle of measure pi over 3 radians, right? The measure of the angle, the radian measure of the angle corresponds to the distance you travel around the circumference of the unit circle, right? And the last video I did on the definitions of radians and all that covers all that. So if you don't understand what I was just saying, go watch that other video. All right, so for pi over 3, I'm going to do the same thing, right? If I go to my angle of pi over 3 and then I do another lap around the circle from there, well, that's going to take me to that same coterminal point. But now that I'm dealing with radians, I can't just add 360 degrees to pi over 3 radians. I have to add the radian measure for a full circle, which is 2 pi. Right? Remember, the full circle, the full revolution is 2 pi radians. So I have to do pi over 3 plus 2 pi. Right? Well, 2 pi, I need to convert that to a fraction with a common denominator is pi over 3. So I'll make it 2 pi over 1. I multiply the top and bottom by 3, which is going to be 6 pi over 3. All right, so instead of 2 pi, let me write that as 6 pi over 3. And you can do that mentally pretty easily. Whatever your denominator is here, which is a 3, the 2 pi, just multiply the 3 times 2, and I get 6, so it's 6 pi over 3. All right, so then pi over 3 plus 6 pi over 3 equals 7 pi over 3. All right, so that's the radian measure of doing one full lap around the circle and then another pi over 3 to get you to that same coterminal point. To get another one, I take that one, 7 pi over 3, I add another 6 pi over 3 to it. That's going to be 13 pi over 3. Another coterminal angle. That would be like doing 2 laps around the circle and then that extra pi over 3 to get me to that same coterminal point. Right? I can get negative angles as well in radians. I go back to pi over 3, and now instead of adding 6 pi over 3, I'll subtract 6 pi over 3. That would be like going to this angle, but then doing a full lap around this way, or what it's going to amount to is starting here and going around there, which is going to be negative 5 pi over 3. Right, 1 pi minus 6 pi is going to be negative 5 pi over 3. And then I can do that again if I wanted to. I can do negative 5 pi over 3 minus another 6 pi over 3, which would be negative 11 pi over 3. Alright, so if I'm finding coterminal angles with degrees, I just add and subtract 360 degrees. If I'm doing coterminal angles with radians, I just add and subtract 2 pi radians. Right? Remember, 2 pi radians is the same as 360 degrees. They both represent a full revolution. Right? It's just when I do the 2 pi radians, if my original thing was in a fraction, I just have to make sure I find the correct common denominator, right? Changing 2 pi to 6 pi over 3, and then I just add 6 pi over 3 or subtract 6 pi over 3 over and over again, and I get my coterminal angles. All right. So there's a couple examples doing one. This should have been a B up here. I forgot to change that letter, but this was example B. I'm going to pause this and put up one more similar example, but a slightly different or worded slightly differently. Alright, the next example I put up here, I put all the work up here too, just so I can talk through it real quick and you don't have to watch me subtracting numbers over and over again. So we're asked to find an angle between 0 degrees and 360 degrees that is coterminal with 1,290 degrees. Alright, so I want to find a coterminal angle. I want my answer to be between 0 and 360, and I'm starting at 1,290. Well, I know that to find coterminal angles in degrees, I just subtract or add 360 degrees, which is one full lap around the circle. So I just do 1290 minus 360 gives me 930, not between 0 and 360. So I do 930 minus 360 gives me 570 degrees, still not between 0 and 360. So I do 570 divided or minus 360, and I get 210 degrees. That one is between 0 and 360. So there's my coterminal angle with 1290, and this one is in between 0 degrees and 360 degrees. And to show that up here, just to give you a visual, right, the 210 degree angle in standard position is from the positive x-axis just past the y-axis a little bit. Actually, that's not right. That's not right at all. 210 degrees should be down over here in the third quadrant. Forget I even drew that picture. Right, that's embarrassing. Right, so it goes all the way around into the third quadrant. The 1290 is doing 3 full labs and then going to that same spot. Right, so another example of finding coterminal angles.